Welcome back to the online lecture on Fundamental of Computer Organization and Embedded Systems. In the last lecture we discussed about input-output module and the functions of input-output module. We saw how input-output module is responsible for data transfer between the peripherals and the processor. In this lecture we will proceed further with the techniques involved in using the input-output module. So the input-output operation techniques. Now data transfers from input-output to the memory through the processor. Now there are two ways or two modes how the data transfers to the processor. Data is transferred from the input-output to the processor. So one is through the processor and one is directly to the memory using the direct memory access. So when the data transferred to the processor is involved in executing the program, that is without interrupts. So whenever a data is to be transferred from the hard disk to the memory, the processor executes a program and instructs the input-output module to transfer data from the hard disk to the memory, and this is what is called as programmed input-output. The another technique that is used for transferring the data is through use of interrupts, so interrupt driven input-output. So in this technique the processor generates an interrupt and directs the input-output module to transfer the data from the disk to the memory in case the data is read from the disk to the memory, and the processor takes on with its own job or executes on its works on its own job. In this case the input-output module accesses the system bus and transfers the data from the disk to the processor. So in both of these techniques the processor is involved and spends its time on monitoring or executing the program for the input-output. To avoid the intervention of the processor every time in moving the data to and fro from the input-output devices to the memory and from memory to the input-output devices, a new technique introduced is the direct memory access. Direct memory access allows the movement of data from input-output devices to the to the memory without the intervention of processor. So as a result, processor is not involved in the data transfer and is able to execute more and more programs at a time. So this reduces the processor intervention in the data transfer, and direct memory access module takes care of the whole data transfer whenever there is a need of data from the input devices to the memory. So the direct memory access, DMA module, so it's a direct memory access. It's an additional module on the system bus that takes care of moving of data from the input devices to the memory using the additional module. This transfers data to and from memory over the system bus. So whenever there is a need of data or processor requests some data from the input devices, a DMA is responsible to transfer the data to and from memory over the system bus. So whenever there is a data transfer between the input devices and the memory, so DMA takes over the system bus and transfers the data without processor's intervention. So DMA uses the bus when the processor doesn't need it. So DMA takes the bus or steals the bus from the processor whenever it doesn't need and uses it for the data transfer. So it's also called cycle stealing. So DMA forces the processor to suspend the operations temporarily so that it can complete its data transfer. So whenever a processor wants to read or write a block of data, it issues the command to the DMA module, and the DMA module takes care of transfer of data between the processor. So issues the command to the DMA module, and DMA module takes the responsibility of transferring the data from the input devices to the processor, to the memory, and so on. So this is the block diagram of DMA. So the DMA also has the control logic, address register, data register, and data count. So this is all connected with the data lines. The address register takes care of the addresses of and accepts the request from the CPU to the DMA. the acknowledgement is sent to the CPU. Interrupt, it also takes care of the interrupt. So interrupt is generated whenever the DMA completes its data transfer from the devices to the memory. So it also has read and write operations. So this is how the DMA functions with the help of various lines. Processor instructs the DMA with various commands to carry on the data transfer. So the processor makes a read and write request using the read-write control lines between the processor and the DMA. So this is where we see the read and write control lines. So these are the read and write control lines that are used to read and write data. Read and write control lines. It also uses address of the input-output devices that are communicated using the data lines. So again you have the data lines here, so that take care of the communication and the addresses of the input-output devices. The processor provides the starting memory location of the data to be read onto the and to be written on the communication lines on the data lines, and the DMA stores the address in the address registers. So this is how these registers play an important role. So address registers store the address of the input-output devices. Data lines carry the data from the input devices to the memory. How much data is to be read? So number of words to be read and written is again communicated on the address register and the data register. So here we can see the address and data register. So these are the registers that store the count and the data address of the data in these registers. So this is how the DMA executes or works for data transfer without intervention of the processor. So DMA can be configured in three different ways: single bus, detached DMA, single bus integrated DMA with IO, and IO bus. So the first mode here you can see the DMA, input output and memory all attached to the same system bus. So this is a system bus. This is a system bus that connects the processor, DMA, input output and memory. So whenever DMA needs to read the data, it takes over the system bus from the processor, and the processor is not able to use the system bus till the entire input output is completed. So DMA takes the data to read the data, takes over the bus to read the data from input output devices to the memory, and again from memory to the CPU, that is the processor. The bus twice for a single data access. So from input output device to the memory and from memory to the processor. Second is the single bus integrated DMA, where all the input output devices are attached to the DMA, as well as the input output module is again attached to the DMA. So this is another way. So here the DMA, whenever DMA is scanning out the communication with the input output devices, it doesn't have to use the system bus in this case. So it uses the input output devices directly, and then the data transfer is done to the memory. Here the processor instructs the input output module to carry out the input process, and the input output module instructs the DMA to carry out the instructions or data transfer. And the third is the IO bus. Now here if you see the system bus is connected only to the processor, DMA and memory. So whenever there is a data transfer between the IO and the DMA doesn't take over the system bus. System bus can be utilized by processor only when the DMA is transferring the data to the memory. At that time the system bus is utilized, and again when the memory is being read by the processor, at that time system bus is utilized. So till the time DMA is dealing with the data transfers, processor is not accessing the system bus, and hence here the DMA takes the entire control of the input output devices with the help of the input output bus. This is how the DMA takes care of data transfer between the memory and the devices. So here we finish up with this chapter. I hope you like the video. Thanks for watching the video. Goodbye.